Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 1876. Substrings of size 3 with distinct characters. A string is good if there are no repeated characters. Given a string S, return the number of good substrings of length 3 in S. Note that if there are multiple occurrences of same substring, every occurrence should be counted. Okay. A substring is a contiguous sequence of characters in a string. So they are asking us to find the good substring among the string of length 3. There may be duplicates also. We want to count them also. Okay, fine. So first of all, what is meant by substring? So substring is something like a subset of a main string where it is in order and also it is in continuous manner or else. Okay. So from this string, I can say XYZ is a substring. Yes. Then ZAZ is a substring, or AZ is a substring, alone Z is also substring, alone X is also substring, alone Y is also substring, like that. Okay. And also the whole string is also a substring. Whether ZAZZ is a substring, like I'm taking ZAZZ. No, it is not in order, right? We can have ZZAZ. Can you understand this? Or else, whether I can have X, Z. No, because I excluded this Y, right? We want to include this Y also because it is not a contiguous, right? But substring is a contiguous manner. So now I hope you understand what is meant by substring. Now see this example. Here they have given, we want to find a substring of length 3 whose are good substring. Okay, first of all, what are the possible substrings from this example of length 3? I can say this is one of my substring, right? Then I can say this is one of my substring. Yes. Then I can say this is one of my substring. Yes. Then I can say this is one of my substring. Can you understand this? Okay. From this blue, whether it is valid good substring. Good substring is something in which there is no repetition, right? But here Z is repeated, so it is not a good substring. Okay, no. Whether this white is a good substring? No. Whether this orange is a good substring? No. Whether this yellow marked substring is a good string? Yes, because X, Y, Z all are different, right? So it is a valid substring. So the answer will be 1. Can you understand this? Yes. So this is what the question states. Now how we can going to do this? Okay, fine. So see here in this explanation itself, what it is saying, we want to take only three characters, right? So the basic approach, a brute force approach that comes to my mind is something in which I'm just iterating from every elements and checking whether the 3 are same, check that 3 are different, that 3 are different, that 3 are different, using a hash set or hash map. You may use anything. Okay, so take for example this same example. Okay, fine. Now I am starting from this X. Okay, now I want to take the first 3 elements and check whether these are same or different using a hash set. Okay, and I want to take this and traverse again to the 3. Okay, then I want to take this set and traverse up to 3, and I want to take this set and traverse up to this 3. That's it. Okay, so this is the brute force approach that comes into my mind. So what is the time complexity and space complexity approach? Sorry, for this approach, so time complexity will be O of, I'm just traversing each and every elements, right? Every character. So it will be N into, I want to again traverse a 3 elements, right? So it will be into 3. Okay, so we are using set, but set is more negligible when I am using this 3 elements. Okay, and what is my space complexity? It is O of, I'm using this set can add up to how much elements? Up to 3 elements, right? So it is also O of 1. So this is my space and time complexity analysis. Hope you understand this, right? Now whether we can still optimize it, because see here it is what, N into 3, it also approximately O of N, but still we can have any other approaches. Yes, we can have other approaches, like just see here, we want to find what are the substring that are of length 3 which are good string, right? So just observe this. I am at this point, at this Y. Okay, and I am checking whether its before element and its after element are different. And also this x and this z are different. If it is so, if here also true, here also true, here also true, then I can say what? Then I can say it is a valid good substring. Then I go to this z, and again I will check whether this two and this two and this two are same. Different. No, this is false, right? This is false. So I will not accept it. Hope you understand this approach, right? So by using this approach, the time and space constraint will be reduced to what? O of n, and here O of 1. That's it. Can you understand this? I am just starting from index of 1 up to n minus 1, n minus 2, up to this I want to go, and I want to check whether its previous element and current element and the next element are different, or everything is different. If it is so, I want to take it into consideration, right? So this is the optimized solution, and we can also have some other alternate solution. Okay, so alternate solution comes here is sliding window. This is the additional solution I want to give you. Okay, sliding window technique. So here they have given that only 3 elements are there. We want to find good substring of size 3, but in actual questions they may ask of k values. Maybe they ask k values, right? In that time we cannot do this approach or this brute force approach to optimal ways, right? See here it is 3 elements, so we done this. But if it is like k is equal to 5 or 6, whether you want to traverse again and again, it becomes a brute force approach. Can you understand this? At that time, the time complexity will goes to up to what? Time complexity will goes to n into k times, right? So to optimize this, what we are going to do? We are going to use a sliding window technique. Okay, let me explain you what is sliding window technique in this approach. Okay, see here. First of all, in sliding window technique, I want to take either a set, or you can also use a hash map. I'm using a hash map, okay, for easy purpose. Okay, first of all, I'm just pointing this as my L pointer and this as my rear pointer. Okay, fine. Now I'm going to take this x. Okay, so take this x and make the count as 1. Perfect. Now just check whether now the length is 3 as of our in question, right? So whether the length is 3, no, and move here. Okay, now whether the size is 3, no, size is greater than 3, no, just take this y and here. Okay, and move. Now what is z? Z. Okay, now whether the size is 3, yes, and we want to check whether the hash map only contains 3 elements, which means what? 3 are unique. That's why the hash map is containing what? Only 3 elements, right? So I can take this as my account. So result will be initially 0, now plus 1. Okay, now I'm just moving my window size. I am going to expand my window size. So R comes here. Now just observe this. It is Z. So add Z as 2. Okay. Now just see here. What is the length? Length is 4, but we want only 3. So shrink it by explaining this x. So x becomes what? 0. Okay. Whenever here something becomes 0, just remove it. Okay. And sorry to say this, I before said that we can use set data, right? But we only use hash map data because we are getting some values like 2, 3. We cannot store that values in set, right? So I told wrong. So now I am deleting this x. Okay. Now again move forward. A. Okay, add A. Okay. Now again just a minute. Now we want to shrink it, right? Because it is greater than 3. Okay, shrink it. Because y becomes what? 0, and pop this out. Whenever some value becomes 0, that should not be in consideration, right? So I am just popping it out. Now the length is 3, but we have only 2 in my hash map, so don't want to update it. Okay, now again go here. So z will becomes what? 3, right? Again shrink it because it is greater than 3. And now how to find the window size? It's r minus l plus 1. This is the formula to find the window size. I have already told you in the introduction video itself, right? I also give the introduction video in my description. Okay, now while shrinking it, I want to make this as 2 minus 1. Okay, now also the hash map only contains 2 elements, but we want 3 elements, right? So it is not unique, so I don't want to add. If take for example, if there is something like b, okay, then what it do, let us see. Now r goes to here. Now b will be taken into consideration. Now the length is 4, so shrink it. Okay, now z should be out of consideration, so -1, it will be 1. Now the hash map is what? 3 elements. We want 3 elements, so just make this as 2. We got another result. That's it. Can you understand this? So this is the sliding window technique. So what is the time complexity of this sliding window technique? I can say n into log n, and space complexity will be what? O of n. Can you understand this? Okay, fine. Okay, fine. Whether we can still optimize it? Yes, we can optimize using what? Frequency array. I don't want to explain this frequency array in this drawing explanation. I directly go for a code. If you don't know about this frequency array, I will give the link in the description. Okay, just go and watch it. So let us see the code such that what is the time constant space of t? You may ask. We are just eliminating this log n. Okay, that's the main purpose, and here it will be 26, which is constant. Okay, let me go. See here, this is the first approach, the optimal approach. Okay, if there is only 3 elements, then we can go with this approach. We are going to check whether the previous and current and next element are different. If it is so, I will increment my result and return the result. Okay, let me submit it once. Yes, it is submitted successfully. Now let us go to the second approach. I told you, right, the hash map approach. First of all, I am taking the result as 0 and the L value is 0. Now frequency, which is the hash map as empty map, and for r in range of, I am going to traverse the s, and s of r is not in the hash map, just initialize as 0, and every time I want to increment by 1. Then if the current window size is greater than 3, then what should I do? I should -1 in the count of s of l, which means the L pointer's character. Now I want to make this what? If I want to check whether that value is 0, is made of 0, then I want to delete the key value pair itself, right? Okay, then L plus equal to 1. I'm shrinking the window size. Now, if the window size is equal to 3, and also the length of the frequency is also 3, okay, then only I want to take what? Result plus 1. Okay, then I want to return the result. That's it. So let me submit it. Yes, it is submitted successfully. Now let us see the frequency array method. So see here, this is the frequency array method. First of all, I want to initialize. Again, I am telling you, just go and watch my video so that you can understand this clearly. I will give the link in the description. Go and watch the frequency array method. Okay. Now I'm just initializing 0 for 26 size, and then same. Everything is same, but see here, this is all different. Order of s of r minus 97. So this is to find the index of the corresponding characters, and I want to take it in the account. Now, if that that window size is greater than 3, then I should shrink it. That's the process done here. Then, if my window size is equal to 3, I want to go and just traverse in every value and check whether any value is greater than 1. Any value's frequency is greater than 1. If it is so, I want to break it. Okay. If it is not so, everything has a value of 1 and 0, then I want to take it in the account. Then I want to return it. Let me submit it. Yes, it is submitted successfully. Thank you.